Hello and welcome. It is Thursday, November 26th. Happy Thanksgiving to those of you who celebrate it. I certainly do. Here's a fun fact about me. It's actually my favorite holiday of the year. But if not, just a happy Thursday. I hope you're all having an excellent day. So we're here to talk about this week's space and astronomy news. So first up, it's kind of some sad news. This is a follow-up to a story I talked about last week with the Arecibo Observatory. So there was an auxiliary cable that snapped back in August, and then as they were working on repairs for that, a main cable snapped earlier this month. So that prompted engineering reviews of the telescope, and unfortunately they found that it's just not safe to repair the telescope, and primarily for safety concerns, the NSF has decided to decommission the Arecibo Observatory. They've been using drones to survey the status of the telescope, and they found just this week that there's actually additional damage to that same tower that had those cables snap, and so it does seem that this telescope, these cables have really reached the end of their lifetime. It's been going strong since the 1960s, and this is really sad news for what is a huge landmark both culturally and scientifically, but safety does have to come first, so the telescope is going to be decommissioned. A really exciting mission just launched from China on Monday. This is the chang'e 5 mission, which is named after the Chinese moon goddess because it's a moon mission. So this is actually a lunar sample return mission. So the goal of the mission is to return about 2 to 4 kilograms of lunar material back to Earth. If this is successful, China will be only the third nation to ever return lunar samples, following the USA and the USSR. And this is the first lunar sample return mission since the 1970s. So this is really exciting. China hasn't released exact details, but it's expected that the sample is supposed to touch down mid-December. So good luck to the chang'e 5. There were 2 really exciting SpaceX launches this week of the Falcon 9. On Saturday, the Sentinel-6 satellite was launched from Vandenberg Air Force Base in California. This is an ocean mapping satellite that's going to be used by NASA and the ESA. And it's named Michael Freilich in honor of the recently departed former head of NASA's Earth Science Division. And on Tuesday, Falcon 9 launched from Cape Canaveral with its payload of 60 Starlink satellites, and this marked the 100th Falcon 9 launch, which is a really exciting milestone. And the booster that was used in this launch was used for the 7th time, which is a new record. We've come a long way since the first SpaceX booster landing on a drone ship in only April of 2016. So in a little over 4 years, they've gone from proving it can be done to doing it as a matter of course, and now they've used this booster 7 times. It's really amazing. Congratulations to SpaceX on 2 successful launches. And speaking of recovering the first stage, this is really exciting news. So Rocket Lab, a New Zealand-based launch company, launched its Return to Sender mission on November 20th from the Launch Complex 1 in New Zealand. This launch not only successfully placed its payload of 30 small satellites into low Earth orbit, but it was also a test of Rocket Lab's ability to recapture the first stage of the Electron rocket that was used. Now, the Electron rocket is smaller than the Falcon 9, so they can't do the sort of propellant-assisted landings on a ship that Falcon 9 does. So their plan is to use a parachute system to slow down the first stage upon reentry and then use a helicopter to capture it, which is really amazing to me. So they've actually already done some tests of the helicopter ability, but this was the first test of the parachute system on re-entry and to see if it could sufficiently slow down the first stage booster. And in fact it did. It was a successful test so far. They did recover the booster from the ocean. It splashed down into the Pacific Ocean. They were able to recover it despite very high seas at the time, and they're doing some tests now to see how well it survived the re-entry process. Now, this particular booster isn't planning to be reused, but this was an important step in the recovering of the first stage booster to prove that it can be done so that going forward they can continue their progress towards having reusable first stage boosters, which would be really exciting, and it would be the second company after SpaceX to do this. And lastly, in some really cool astronomy news, the CNO collaboration published a paper in Nature yesterday announcing that they have detected solar neutrinos that have resulted from the CNO cycle. So to give you a little context, neutrinos are very small particles with almost but not quite zero mass that are released during lots of processes, but importantly in this case, during the fusion processes that basically power the sun. The sun is an enormous fusion reactor and it produces a lot of neutrinos. However, these are very difficult to detect because neutrinos don't like to interact with matter. They basically pass straight through the Earth. You have billions of neutrinos passing through you every second of the day. So they're very difficult to detect, but scientists have been able to do it, and in fact they first detected solar neutrinos back in the 1960s. Now, the majority of the neutrinos in the sun are produced from what's called the PP chain, or the proton-proton chain, which is basically 2 protons interacting in various ways. Not going to get into the details, but basically this produces 99% of the sun's energy, and we've detected and characterized these neutrinos. We can create a whole spectrum of them. However, 1% of the sun's energy comes from a different process called the CNO cycle. So the CNO cycle is the carbon, nitrogen, oxygen cycle. And it actually doesn't produce carbon, nitrogen, and oxygen, but it uses them as catalysts for a cycle, basically. And this cycle also produces neutrinos. However, one, it's only 1%, so there's a lot fewer of them, and two, there are a lot lower energy neutrinos than the PP chain neutrinos. So they had not previously been detected until now. So now the Borax-CNO collaboration has detected these solar neutrinos, which is really exciting news. Because neutrinos interact so weakly with matter, they basically pass directly through the sun, and so they really can help us probe the very deep interior of the sun where this fusion is actually happening, unlike, say, photons, which interact heavily with the rest of the sun on their way out. So it's really exciting news that we can detect this. The CNO cycle is very important in higher mass stars than the sun. It can give us a hint about the metallicity involved in the stars. And when astronomers say metallicity, they basically mean anything that's not hydrogen or helium. It's a confusing convention, but here we are. So this is really exciting news. Congratulations to the Borax-CNO collaboration, and looking forward to seeing what more science can come out of this. Well, there you have it. That's this week's Space and Astronomy news, Thanksgiving edition. I hope that you all are staying safe. I know I will personally be celebrating alone at home, but that doesn't mean I'm not going to have 3 different kinds of dessert because I like to bake. I'm so thankful for all of my viewers and all of the people that love science, love space, love astronomy just like I do. And I hope I will see you again soon. Bye!